Deviations from the law of one price, and from the law of one price, which applies at the individual level, we now want to look at the evidence on PPP, which is more at the macro level. Okay, and there is a huge literature on PPP, and you could have a whole course just on the PPP literature. We will not cover all of this, but maybe about half of this to give you a good sense of what has been done. Okay, so let's get started. Now, absolute PPP, of course, means the nominal exchange rate is the ratio of the two countries' price levels. Relative PPP expresses the same thing in percentage changes. So the early empirical literature was basically running regressions of this kind. Okay, so you're regressing the log of the nominal exchange rate on the domestic and foreign price levels. So basically, we know that absolute PPP is telling us that the nominal exchange rate should be something like this, ratio of the national price levels. And so, in log terms, we have something like this. And so these we express, the log levels we express in lowercase. So we have this. So this is what absolute PPP is saying. How can we test this? Well, you run a regression of S on a constant. Okay, and if PPP holds, then you should get okay, so that's a simple way of testing PPP. Sorry, I forgot to add an error term over here. So you do a regression of this type, and then you test whether these coefficients are 1 and -1. And if they are, then you would conclude that PPP holds. And these are just ordinary least squares kind of regressions. So you do this kind of a regression, and a test of these restrictions that beta is 1, beta star -1 would be interpreted as a test of absolute PPP. Whereas if you do the same regression but in first differences, so if you do this regression in first differences, so you have the percentage change in the nominal exchange rate, you regress that on a percentage change in the price levels or the inflation rates, and that would be a test of relative PPP. And in particular, the literature talks about this distinction, okay? So it talks about a symmetry condition. Symmetry means that the magnitude of beta and beta star should be the same, symmetry condition. And the other condition, the proportionality condition, is that their absolute values should be 1. Okay. So why do we relax? So when we talk about symmetry, the two betas are the same, but they could be different from one. And the reason we want to allow for a departure from one is because maybe imposing beta equal to 1 may be too strong, because in the construction of price indices, there may be measurement errors of various kinds that may cause these coefficients to be different from 1. And right? So the price levels could have a significant impact on the nominal exchange rate, but it could be different from 1. And you wouldn't want to say that PPP does not hold at all. Okay? It holds, but not perfectly. Okay, so they're equal and opposite sign, the symmetry condition, and they're equal to unity, that's proportionality condition. Now, of course, in this early literature, the researchers did not study the dynamics of this relationship, so they did not distinguish between the short run and long run effects, even though intuitively we may think that PPP may work better in the long run. Right? Short run, the departures may not be eliminated so easily. And most of the empirical literature based on this kind of equation generally rejects the PPP hypothesis. Okay? One important exception was a paper by Frenkel, and he got estimates of beta and beta star close to plus and minus 1, but that was only for high inflation countries. Okay? So again, high inflation countries means most of the underlying shocks are monetary shocks. With monetary shocks, there is some evidence that PPP seems to hold. In other cases, we have doubts, but most of the literature rejects the PPP hypothesis. But of course, a big problem with this literature is that they don't look at the properties of the residuals, and they don't test for stationarity. Okay, so all these papers, there's a huge problem from an econometric point of view. This whole literature could be completely invalid. Okay, but you can't blame them because the concept of co-integration just wasn't available to them at that time. Okay, so. Now, another problem in using this kind of equation is endogeneity. Okay? Nominal exchange rates and price levels, they're both endogenous, they're all endogenous variables, and so you have to correct for the endogeneity bias. You cannot just run a regression, and so Krugman in particular tried to do that. He tried to estimate this model using instrumental variables to correct for the endogeneity bias. And when he did that, then he found that beta and beta star were close to 1 to their theoretical values as implied by PPP, but PPP was still rejected. Okay? But the big problem with this early literature is that they don't investigate the stationarity of the residuals in the estimated equation. And we know that if the nominal exchange rates and relative prices are non-stationary and they are not co-integrated, then the regression would simply be a spurious regression. We cannot have any meaningful interpretation. Okay? So conventional OLS-based statistical inference is invalid. Okay? And if the error term is stationary, then there is a co-integration, So there is a strong long-run relationship between exchange rates and prices. But conventional inference is still invalid. Okay, the OLS cannot be used for statistical inference, as we have learned already. Okay, so the next stage in the development of this literature was explicitly to address the issue of non-stationarity, starting with an analysis of whether the real exchange rate itself is stationary, implying evidence of long-run PPP. Okay, so, and this is the reason why we study unit roots and cointegration in so much detail. Okay, so the real exchange rate in its log form, we can write it like this, right? So QT is the log of the real exchange rate. So simple way of testing absolute PPP. Sorry, so this is all. Okay, so we define the real exchange rate. Okay, price level in the home country, price level in the foreign country, times the nominal exchange rate. So always good to remember the units. Okay, so suppose the home country is Hong Kong, so the price level here is in Hong Kong dollars. The foreign country, let's say, is the US, so this price level is in US dollars. Then the nominal exchange rate is going to be Hong Kong dollars per US dollar. Okay, so the units, we have to be consistent in how we use them. So then the real exchange rate would be the relative price of Hong Kong goods to US goods. And log of this real exchange rate, we call that Q, log of the home price minus log of the nominal exchange rate minus log of the foreign price. So Q would be PH minus S minus PM, something like this. And if and PPP would imply that Q should be 0, right? Q should be 0 if PPP holds, but in practice, we don't expect PPP to exactly hold because these price levels, from different baskets, different base years, measurement errors, and so on. So for many reasons, we don't expect Q to be exactly equal to 0, but Q should at least be stationary. Okay, so we want to allow for some deviations from constancy. It doesn't have to be constant or 0 exactly, but it should at least be stationary. The real exchange rate should at least be stationary. That's what PPP tells us. Okay? So we want to see, is the real exchange rate stationary? Is it I0 or is it I1? So that's one way in which we can test PPP. So he's defining it a little differently than I am. Relative price of home to foreign, okay? I'm defining it the other way. Either way is fine as long as we are clear about the differential. Okay, so all these early papers, they're trying to test for the non-stationarity of the real exchange rate. And how do they do it? Well, some version of augmented decay for that test, right? So you look at the real exchange rate, and then you do the ADF regression. Here you allow for a constant, possibly a time trend. Then you include enough lags to absorb the serial correlation, and you want to test whether this coefficient gamma 2 is 0. So under the null of a unit root, gamma 2 would be 0. Under the alternative, gamma 2 would be positive or negative? Under the null of a unit root, gamma 2 is 0. And under the alternative of stationarity, gamma 2 would be positive or negative? Negative. Okay, it should be negative. Less than 0. Okay? So that's the standard test, and you all know how to do it. The alternative hypothesis that PPP holds requires that, oh, now it's gamma 1. So there's a typo. Okay, so it should be gamma 2 is less than 0. Gamma 2 equals 0 versus less than 0. So you can change this to gamma 2. Okay, now that's the ADF test, and a variant of this approach is to use a modified version of the ADF test, which we call the Phillips-Perron test. We have also learned how to do this. Okay. Now, another way, a second approach to testing for non-stationarity involves variance ratio tests. Okay. So, in this case, the persistence of the real exchange rate is measured using the simple non-parametric test, originally due to Cochrane. And so that's, you look at ZK, that's the test statistic. You're comparing the variance of the change in the real exchange rate over K periods. You divide that by K times the variance of the change in one period, okay? Where K is a positive integer and this is the variance. Now, if the real exchange rate follows a random walk, that means the real exchange rate has a unit root, it follows a random walk, then this ratio would equal 1. By contrast, if the real exchange rate exhibits mean reversion, this ratio would be between 0 and 1. So maybe I'll explain that a little bit further. So this is ZK. Okay. So that's the ratio of these two variances. Okay. H naught is that real exchange rate let's say is a random walk, follows a random walk. That means it has a unit root, and in this case PPP fails. The alternative is that the real exchange rate is stationary, is I0. Okay? Now, under the null hypothesis, So we could write the real exchange rate something like this. And that's a random walk. That's a random walk process. So under the null hypothesis, the real exchange rate follows a random walk. So that means that the 1 period change in the real exchange rate, that's just epsilon. So the variance of this 1 period change is just the variance of this white noise process, some constant sigma square. Now, what about the k period change in the real exchange rate? Well, the k period change we can write as follows. Right, so we can break up this k period change into several 1 period changes, and this would just be the sum of these k error terms. So the variance of the k period change, because these epsilons are white noise, they have no covariance, so it's just sigma square plus sigma square plus sigma square, so k times sigma square. So therefore, under the null hypothesis, zk is going to be, right, the numerator is the k period change, and the denominator is k times the 1 period change. So under the null hypothesis, zk will be 1. And what is the intuition over here? Well, if the real exchange rate is really, it has a random walk component, then the k period change, there is no mean reversion. So the k period change will essentially be like the sum of k 1 period changes. Okay? But if there is mean reversion in the real exchange rate, then this ratio should be smaller than 1. Okay? Because over k periods, you will kind of tend to mean revert. And so the denominator will become smaller than, the numerator will become smaller than the denominator. So if there is no mean reversion, okay, that means the real exchange rate has a unit root, then the numerator and denominator, they are the same. Okay? But if there is mean reversion, the numerator will be smaller than the denominator. The k period change will be less than k times the 1 period change. Right? If all the changes are independent and permanent, then this ratio should always be 1. But if there is mean reversion, then this big change should be smaller than k times the 1 period change. So that is the intuition behind this variance ratio test. So under H0, this is 1, and under H1, it's going to be smaller than 1. So that's another way to test whether the real exchange rate is stationary or not. A third approach is based on fractional integration. Okay, so this is more technical. I'm not going to talk about this, so let's skip fractional integration. Okay, then we move on to co-integration. So co-integration seems to be an ideal approach for testing PPP. And now we can think of QT, the real exchange rate. We can think of it as the equilibrium error. That's the deviation from PPP. Okay, so a necessary condition for PPP to hold is that the real exchange rate should be stationary over time. And if that's not the case, the nominal exchange rate and relative prices will permanently tend to diverge. And co-integration tells us that any two non-stationary series which are found to be integrated of the same order, they are co-integrated if a linear combination of the two exists, which itself is stationary. So the non-stationarity of one offsets that of the other, and a long-run relationship is established between them. So here we can think of ZT as a linear combination of the nominal exchange rate in log terms, and pi is the relative price level of the home and foreign countries. So some combination, some linear combination should be stationary. Okay? The notation here is a little bit ugly. So basically what they are saying is, suppose we have two variables. One is the relative price, pi t, p minus p star. The other is the nominal exchange rate. Both are integrated of order d. Okay? Normally, for us, they are integrated of order 1. Okay? We are not talking about higher orders, but the idea is more general. Okay? So they're integrated of order d. Their linear combination in general will also be integrated of order d. But if they are co-integrated, then the linear combination will be integrated of order d minus c. That means it will be integrated of a lower order than these two individual variables. But of course, in the context of PPP, d is equal to c is equal to 1. So nominal exchange rate and prices, they're both I1, but z should be I0. The real exchange rate should be I0. Now, of course, if we do not find co-integration, so if the no co-integration hypothesis cannot be rejected, then the estimated regression is spurious and has no economic meaning. So that's clear. Okay. Now, what is the difference? So we talked about testing for a unit root in the real exchange rate. You could do that. Or you could test for co-integration between the nominal exchange rate and the price levels. What is the difference between these two approaches? Okay, so when we are looking for co-integration, we are allowing for the possibility that this k could be different from 1. Okay, so we are not imposing symmetry and proportionality. So when we construct the real exchange rate, you can see we are imposing coefficient of 1 over here and minus 1 over here. Okay? So if we are testing whether Q is stationary or not, we are imposing symmetry and proportionality by construction. It is embedded in the real exchange rate that the coefficient of home price should be +1, coefficient of the foreign price should be -1. Okay? But if we are doing a regression, of nominal exchange rate on this price differential, we are allowing for non-unity coefficient. Okay? So nominal exchange rate will be co-integrated with this relative prices with some coefficient different than 1. Okay? So slightly more flexible. Okay, the test is slightly more flexible when you are testing for co-integration. For example, if you're doing a regression like this, okay, so here beta and beta star could be different from each other and from the unit value. So I could just test whether the nominal exchange rate is co-integrated with the home and foreign prices. These coefficients don't have to be 1 and -1. Or if they turn out to be 1 and -1, then that's great. Okay? But suppose they are not. Suppose this is 0.9 and this is -0.8. But epsilon is stationary so that there is co-integration. Would we say that we reject PPP completely? No. Okay, there's still a long-run relationship between nominal exchange rate, home and foreign prices. It's different from what absolute PPP implies, but you cannot say that you completely reject absolute PPP because of a small deviation of beta and beta star from 1 and -1. So co-integration allows beta and beta star to be different from the theoretical values, but you still could see if there is a long-run relationship between exchange rate and prices. So that's the difference. Co-integration gives you a bit more flexibility. Okay, so that's the main difference, is that symmetry and proportionality are not imposed. And why you don't want to impose them? Well, maybe because of measurement errors between the measured price indexes and the correct ones. Maybe there are barriers to trade, transportation costs, blah, blah, blah. Okay, so one way is to test. So you could test for co-integration and then do inference on the estimated coefficients. So for example, by using the Johansson co-integration test, you could actually get the correct standard errors and test whether symmetry and proportionality hold in the data. Okay? So when researchers did these co-integration studies, they generally reported the absence of significant mean reversion of exchange rate towards PPP for the floating rate period. So before 1973, you know that there was a Bretton Woods agreement in place, and most countries had stable nominal exchange rates which were fixed. Okay? But after 1973, the Bretton Woods agreement broke down, and most exchange rates of the large developing countries, they were floating, and they are still floating today. Okay? So once the Bretton Woods agreement broke down, people found that PPP tended not to hold. They could not find evidence of co-integration between exchange rate and the relative price levels. Okay, so so that's the overall conclusion. So overall, co-integration studies highlight some important features of the data. First, you can reject the null hypothesis of no co-integration when exchange rates are fixed rather than floating. Okay, so PPP tends to work better under fixed nominal exchange rates rather than floating nominal exchange rates. So floating nominal exchange rates introduce a lot of volatility and cause a breakdown of PPP. Okay. Second, stronger evidence supporting PPP is found when you use the wholesale price index rather than the CPI. Okay. Even more so than the GDP deflator. And the reason for that, well, is easy to guess. The wholesale price index has a very small proportion of non-tradables. So it's mostly tradables, and we expect PPP to work better for goods that are actually traded. Okay, so that's another finding. So that's basically a summary of the co-integration literature. Disappointing findings, symmetry and proportionality are very often rejected. Okay, estimated parameters are often far from theoretical values. So they are not even close to 1 and minus 1. Why this happens, it's not so clear. Okay, but one important conclusion from this literature, so maybe small sample bias, and one problem that researchers think is simply longer data sets are needed to detect PPP and mean reversion. Okay, so one problem is that, so think about a unit root test. We discussed earlier that the power of the unit root tests depends on the length of the data that you have. Right? The longer the span of your data, the more powerful your unit root and co-integration tests are going to be. Okay, so I want to talk about this power problem. So a number of authors have noted that tests for examining long-run PPP may have very low power to reject the null hypothesis of real exchange rate instability when applied to data for the floating rate period alone. Okay, so the problem is the Bretton Woods Agreement broke down in 1973. So if you look only at the post-Bretton Woods period after 1973, then you have 30 years of data, maybe 40 years of data for most countries. And that is simply not enough to make your unit root tests sufficiently powerful. Okay? And a very famous paper by Luthein and Taylor studies this issue of low power. Okay, so let's take a look at this paper. I think we can finish this paper for today and then. So most tests of PPP that are based on unit roots and co-integration, they find that they cannot reject the null hypothesis of a unit root in the real exchange rate, so they conclude that PPP does not hold. Okay? But Luthein and Taylor, they argue that, well, these rejections that most researchers find, these rejections of PPP may be because of the small floating period samples that researchers focus on. So their contribution is they collect data for 200 years, okay? And then they test for unit root in the real exchange rate, okay? So that's, it's a very nice paper. So let's see. So in this paper, they investigate long-run mean reverting properties of real exchange rates and examine whether any additional insight can be gained by considering the recent floating period from the perspective of data reaching much further back into history. So they assemble the longest currently available exchange rate and price level data for these three countries, US, UK, and France. And it spans 200 years from 1791 to 1990. Okay. So what's the motivation for this? Well, we have concerns that tests of unit roots, they have very low they have very low power, especially during the current floating rate. And potential problems arise when you try to increase power by incorporating free float observations. So if you try to extend the data, on the one hand, you're getting more observations, so your power should increase. But on the other hand, you're also mixing data from different regimes. You have fixed regime, floating regime, gold, a period when currencies were backed by gold or other metals, all kinds of regimes over the last 200 years. Can you just mix them together? Could there be structural breaks? So all these issues have been studied here. Okay. Now, what happened? So before the Bretton Woods broke down, so in the pre-float period, most studies, they found that the real exchange rate was fairly stable. It means it's stationary, so PPP tends to hold. And then in the empirical models, they started incorporating this assumption. So in monetary models, for example, they assume that PPP holds. And not just that it holds, in some models they even assume that it holds at every point in time on a continuous basis. And that's because when they observed in the fixed exchange rate regime, PPP did tend to hold. The real exchange rate was fairly stable. But once the Bretton Woods arrangement broke down, then nominal exchange rates became crazy, very, very volatile, and then they observed the apparent collapse of PPP under floating exchange rate regime. So very high variance of real exchange rates. And then that became a force for rewriting the theory. So then researchers had to develop different models like the sticky price overshooting model of Dornbusch, which we will study later in the course. Okay? So once exchange rates became floating, then you could not reject the hypothesis of a unit root in the real exchange rate. So such a big change in how we view PPP. So before Bretton Woods, economists were assuming PPP holds, not just that it holds continuously in every period of time. After Bretton Woods, it doesn't hold. Not only does it not hold, it does not hold even in the very long run. All changes in real exchange rates are permanent changes, random walk. Okay? So from a constant real exchange rate, right, PPP holding continuously, you go to the other extreme of PPP not holding even in the long run. So that's a huge change. So the sentiment shifted. Okay. So then people started thinking, well, maybe PPP is completely useless. Okay. You cannot use PPP for formulating any kind of policy related to exchange rates, because PPP doesn't hold even over long periods of time, the breakdown of PPP. And then more recently, even that view has come into questions as studies find, well, it's not a pure, so PPP, real exchange rates are very persistent, but they are not a pure random walk. So there is some kind of mean reversion going on in real exchange rates. Okay, so somewhere in between. Now, many researchers then said that, well, maybe it's the power of the tests over short sample periods. Okay, so they argued that the difference in the length of data series could be important. So that's the motivation for this paper. Okay, so let's see what happens. So on the PPP, nominal exchange rate proportional to ratio of price levels. This is the real exchange rate. That's the deviation from PPP. Everything be held continuously, QT will be constant. But the sample variance of QT over the recent float is very large, and that provides strong and clear evidence against continuous PPP. But they are asking, well, so in the short run, PPP absolutely fails to hold, but what about the long run? What about the long run? So they construct annual observations on the dollar, pound, and the franc pound exchange rates and wholesale price indexes for about 2 centuries. So you can look at that. Now, this is log of the US sterling real exchange rate over this 2-century period. Okay. Does it look stationary or unit root? You just look at a picture of this, stationary or unit root? Looks stationary, right? Looks quite stationary. Now suppose you have only, you're looking at the floating period, so that's roughly only this much. Okay? Does it look stationary or non-stationary? Okay, right? Looks non-stationary. So it just changes your perspective if you have 200 years of data. And that's the other real exchange rate between France and the UK. This looks even more stationary than the other one. Okay, so what do? Okay, so they're using, so they construct a real exchange rate for 200 years, and then they apply the Dickey-Fuller and the Phillips-Perron unit root tests, okay, which we have learned. And let's look at the results. So these are unit root tests for real exchange rates. Okay. Again, the null hypothesis is that there is a unit root in the real exchange rate. And these are the ADF tests, and Phillips-Perron, different kinds, with trend, with intercept and trend both, and so on. Okay? So you can see for the full sample, this is the full sample, a 200-year sample, you can reject the null of a unit root for the dollar sterling real exchange rate. They're all significant. Second sample is up to the Second World War, from 1791 to 1945, up to World War II. Again, you can reject the null of a unit root. Third sample is the post-war period, 46 to 1990. You cannot reject the null of a unit root. And the last sample is after Bretton Woods. You cannot reject the null of a unit root. So they're saying, well, this is clearly an issue of low power. Okay? In the post-Bretton Woods or even post-World War II, your power is too small to reject the null of a unit root. But if you have passed the 200 years, the full sample, or most of the sample, then you can easily reject the null of a unit root. If you look at franc sterling, then you get similar results. Full sample up to the Second World War, you can easily reject the null of a unit root. Post-World War II and post-Bretton Woods, you cannot reject the null of a unit root. Okay? Then in the next table, and they're saying, well, let's look at some other periods. Right? Post-World War, we have about 45 to 50 years of data. So if they look at other periods that are 45 to 50 years, once again, they cannot reject the null of a unit root. So their conclusion is that the rejection of PPP is being caused due to the low power of the unit root tests. Now, okay, I'll stop here for now. We'll finish it next time. Okay.